Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Welcome back to Mystery of Excel Function, VAR. Today, we're diving deep into the VAR function, a powerful tool for analyzing data dispersion. As a structural engineer, I'm passionate about using Excel to enhance my work. Mastering Excel is a journey, not a destination, and this function is a crucial step. The VAR function calculates the variance of a data set, measuring how spread out your data points are. Imagine you're analyzing the strength of concrete cubes. A high variance means the cubes have a wide range of strengths, while a low variance indicates consistent results. Real-world application of VAR function. In civil engineering, the VAR function is invaluable for tasks like analyzing the variation in material properties, assessing the reliability of construction methods, identifying potential outliers in data. By understanding and applying the VAR function, you can make more informed decisions and improve your engineering projects. Ready to unlock the power of the VAR function? Let's dive into the practical examples and learn how to use it effectively in your Excel spreadsheets. Don't forget to like, subscribe, and share this video to support my channel and stay updated on future Excel tutorials. Let's delve deeper into the VAR function and understand the manual calculations behind it. While Excel automates the process, it's essential to grasp the underlying concepts. Imagine a data set of 11 people's heights, ranging from 70 to 80 inches. Our goal is to calculate the variance, which measures how spread out these heights are. A high variance indicates a wider range of heights, while a low variance suggests more consistency. Manual calculation steps. Step 1. Sum of heights. Add up all the heights to get the total. Step 2. Mean height. Calculate the average height by dividing the total by the number of people. Step 3. Difference from mean. Subtract the mean from each individual height. Step 4. Squaring differences. Square each difference to eliminate negative values and ensure equal weight. Step 5. Sum of squared differences. Add up all the squared differences. Step 6. Variance calculation. Divide the sum of squared differences by the number of people minus 1. The VAR function in Excel seamlessly performs these steps, saving you time and effort. By inputting your data into the VAR function, Excel calculates the mean, differences, squares, sums, and finally, the variance. In our example, a variance of 11 indicates a moderate spread in the heights. This means the heights are neither too close together nor too far apart. The desired level of variance depends on the specific context and goals of the analysis. For example, low variance, in engineering or manufacturing, consistent results, low variance, are often preferred. For instance, in concrete cube testing, reliable material quality is ensured with minimal variation in strength. High variance, a wider range, high variance, might be desirable in other scenarios. For instance, a YouTuber analyzing viewer ages would benefit from a diverse audience, which implies a higher variance in age distribution. By understanding the manual calculations behind the VAR function and the importance of desired variance, you can apply this powerful tool more effectively in your Excel projects. Whether you're analyzing data in engineering, finance, or any other field, the VAR function is a valuable asset for understanding data distribution. In Excel, the VAR function family offers a variety of options for calculating variance, a statistical measure that indicates how spread out data points are. Let's explore the different VAR functions and their uses. VAR. The standard VAR function is used to calculate the variance of a sample. This means it's suitable when you have a subset of data from a larger population. VARP. VARP is used to calculate the variance of a population. This is appropriate when you have the entire data set, not just a sample. VARPA. Similar to VAR, VARPA handles datasets that include text or logical values. It treats these values as errors, excluding them from the calculation. VARA. VARA is also used for calculating the variance of a dataset that includes text or logical values. However, unlike VARPA, it treats these values as zero. VAR.S and VAR.P. These newer functions are more specific in indicating whether you're calculating the variance of a sample, VAR.S, or a population, VAR.P. They offer the same functionality as VAR and VARP, respectively. The choice of VAR function depends on the nature of your data. If you have a sample, use VAR or VAR.S. For a population, use VARP or VAR.P. If your data includes text or logical values, consider VARA or VARPA. By understanding the different VAR functions and their uses, you can effectively analyze the spread of data in your Excel worksheets and make informed decisions based on your findings. Now I am switching over to my Excel dashboard for the demonstration of VAR function in Excel. 21. VAR. Now, let's put the VAR function into action. I've prepared a dataset in cells F3 to P3, containing numbers from 70 to 80. To calculate the variance of these numbers, follow these steps. Step 1. Insert the formula, in a cells, example G4 to 04, enter the formula equals VAR. Step 2. Select the data range, select cells F3 to P3, by pressing the left click of the mouse. Step 3. Press enter, Excel will calculate the variance. In this case, the result is 11, which matches the manual calculation we performed earlier. As you've seen, the VAR function is a powerful and efficient tool for calculating variance in Excel. By following these simple steps, you can quickly analyze the spread of your data. Excel function number 22, VAR.S. Now by the help of drop-down menu I am switching over to the function VAR.S and to change the function from VAR to VAR.S in the merged cell, G4 to 04, just by typing .s after VAR. We already know that function, VAR.S offer the same functionality as VAR. Hence we are getting the same result, 11. Excel function number 23, VARPA. Let's explore the VARPA function, which calculates the population variance of a data set. This is different from VAR, which is used for sample variance. Let's try function VARPA on the same data, ranging from 70 to 80. Our goal is to calculate the population variance using VARPA. Steps for the VARPA function. Step 1. Insert the VARPA formula, in cell G4, enter the formula equals VARPA, F3P3. Step 2, select the data range. We have already selected the cells from F3 to P3. Step 3, press enter. Excel will calculate the population variance. The result will be 10, indicating the spread of heights within this population. Key difference: population versus sample. 1. The key difference between VARPA and VAR lies in how they handle the divisor. 2. VARPA divides by the population size, n. Here it is 11. 3. VAR divides by n1 for sample variance. Here it is 11 minus 1 equals to 10. Use VARPA when you have data for the entire population, and use VAR when you have a sample of data. By understanding the VARPA function and its distinction from VAR, you can effectively analyze population data and gain valuable insights into its distribution. Handling text values. The VARPA function treats text values as errors and excludes them from the calculation. To demonstrate this, let's replace the value in cell F3 with the text A. Excel recalculated the in cell G4, and the result changes from 10 to 478.59504. This is because VARPA ignored the text value and calculated the variance based on the remaining numerical data. Excel function number 24, VARP. Let's try function VARP on the same data, ranging from 70 to 80. Our goal is to calculate the population variance using VARP. Switching to VARP. To switch from VARPA to VARP, simply edit the formula in cell G4 by delete A from VARPA. This will change the formula to equals VARP, F3P3. Press enter. Excel will calculate the population variance. The result will be 10, indicating the spread of heights within this population. Handling text values. The VARP function, like VARPA, treats text values as errors. To demonstrate this, let's replace the value in cell F3 with the text A. When you recalculate the formula, the result will change from 10 to 8.25. This is because VARP ignored the text value, A, and calculated the variance based on the remaining numerical data. VARP is a versatile function for calculating population variance. It effectively handles text values and provides accurate results based on numerical data. Excel function number 25, VAR.P. Switching to VAR.P. To switch from VARP to VAR.P, simply edit the formula in cell G4 by adding a period before the P. This will change the formula to equals VAR.P, F3P3. Press enter, and you'll see that the result remains 10. VAR.P offers the same functionality as VARP. Both functions calculate the population variance and handle text values as errors. Handling text values. To demonstrate this, let's replace the value in cell F3 with the text A. When you recalculate the formula, the result will change from 10 to 8.25, confirming that VAR.P ignores text values and calculates variance based on the remaining numerical data. VAR.P is an alternative syntax for calculating population variance in Excel. It provides the same functionality as VARP and effectively handles text values. Excel function number 26, VARA. Let's explore the VARA function, which calculates the variance of a data set, including text values as 0. Switching to VARA, to switch from VAR.P to VARA, edit the formula in cell G4 by adding a period before the A. This will change the formula to equals VARA, F3P3. Press enter, and you'll see the result 11. VARA offers the same functionality as VAR when all data points are numbers. Handling text values, the VARA function treats text values as 0 and includes them in the calculation. To demonstrate this, let's replace the value in cell F3 with the text A. When you recalculate the formula, the result will change from 11 to 526.45455. This is because VARA included the text value as 0 in the calculation. VARA is a versatile function that can handle both numerical and text data. It treats text values as 0, which can affect the calculated variance. That concludes our exploration of the VAR, VAR.P, VARA, and VARPA functions. These functions are essential tools for understanding data dispersion in Excel. In our next video, we'll delve deeper into intermediate Excel concepts. Stay tuned for more advanced techniques and tips that will elevate your Excel skills. Thank you for watching. If you found this video helpful, please consider subscribing, liking, and sharing to support my channel and reach more learners.